Okay, now we are going to study action and reaction forces and force of friction. From Newton's third law of motion, we know that there are for every action there is an equal and opposite reaction. Similarly, forces always act in pairs and they always act in opposite directions. It is not necessary that they are equal in magnitude, but they are in opposite directions for sure. Now, let us consider a pile of books on the table. Now, this pile of books is exerting a force on the table in downwards direction because of its weight, and in reaction to that, the table is exerting a normal force on the books in upwards direction. So weight is downward, and pairing it, there is a normal force in upward direction. So in this instance, both of these are in equal in magnitude and opposite in direction. That's why the objects are, or the book is imbalanced because the forces are balancing out each other. Now let us consider two objects. Uh, there is a box and a vase laying on the table, and vase is in contact with box as well. So there are 3 points of contacts where forces will be acting: point A, point B, and point C. So on point A, box will be exerting force on the table in the form of weight in downward direction, and table will be exerting a normal force in reaction to the weight. Both will be equal in magnitude and opposite in direction because they are balancing out each other, and the object is in equilibrium condition. And on point B, was is exerting force in the form of weight acting downwards on the table, and table is producing an equal and opposite reaction in the form of normal force. And then in point C, the was is exerting force in the direction of red arrow, which is the action of the was, and then in return, in response to that, the box is exerting a normal force or the reaction which is opposite to the action of the was. So they are equal and opposite in, they're equal in magnitude and opposite in direction. If they are not, the condition will be unbalanced and they will not stay in the present situation for long. According to Newton's third law of motion, when two bodies interact with each other, the forces of the bodies on each other are always equal in magnitude and opposite in direction. Now let us consider these two bodies in the form of boxes, like blocks A and B. Now if the block A leans against block B, it exerts a force on object B at the point of contact. So that force will be represented as FBA, like this, in the direction of yellow arrow. So FBA is the force exerted by object A on object B. Now object B will also exert a force which will be equal in magnitude and opposite in direction to the force that is applied by the object A. That will be the reaction force, like this. So FAB is the force which is exerted by object B in reaction to the force which was exerted by the object A. So these forces are equal in magnitude but opposite in direction. In this situation, both of these objects will stay in this condition in equilibrium without falling down. Now these two forces are equal in magnitude, means FAB is equal to FBA, but opposite in direction. Notice the overhead arrows. So in magnitude we do not need to mention those, and we do not need to draw those, but in the vector form we need to draw those, and the negative sign matters because magnitude cannot be negative, so we do not need to write negative sign with magnitude, but in the vector form it represents the opposite direction. That's why it is important to mention negative sign. So there are two you know that we have two different notations for to represent vectors. One is boldface and one is overhead arrows. So to me, overhead arrow is more noticeable than boldface. That's why I prefer to use overhead arrows. So these two forces are making a pair, and this is such a pair that they have equal magnitudes but opposite directions, and such a pair is also called as third law force pair because it is related with Newton's third law of motion. Okay, uh, now let's move towards frictional forces. Frictional forces are very important in our daily life. On one hand, they make means they are disadvantages for us because but these forces cause the tires to means to wear down, and it dissipates our energies in the engines, and it dissipates our means it slowly it wears down the mechanical parts, and which reduces the life of device, electrical device and mechanical devices like that. And it also it wears the soles of our shoes that we are wearing for a long time. After us means as the time passes, we keep on using them. The friction between the sole of the shoe and the road make them wear out soon. If the friction is more, the surfaces are rough, our shoes will wear out faster than if the surfaces if we do not have means if we are not moving on the if you're moving on the frictionless surface, like in the ideal case our shoes will never wear off like they do in our real life. But without friction, so many things that are very good and very useful for us in our daily lives will never occur. Like for example, we will never be able to write because in order to hold pencil in our hand we need frictional force to keep it in my hand. And if there is no frictional force between the the lead of the pencil and the paper, the lead will never leave any mark on the paper and we will not be able to see any writing on the paper. And these nails, these tools will be useless because the grip of the nail or screw inside inside a device or means the objects that we have made by that we have joined by inserting screws and nails in them will be useless because there will be no grip. So the grip of the nails and screws is because of the frictional force. If there is no friction, they will be useless, and we will never be able to walk or run on the ground because this is the frictional force that provides us grip on the road, and it makes us it enables us to move. That's why frictional force is very important in our for our daily life activities. Okay, now let us consider a wooden box which is laying on a wooden floor. In this equilibrium condition, there are two forces acting on it. One is its weight downwards, which is we can write it as Fg, or gravitational force, which is equal to the weight of the block of the wooden block, and a normal force because on the box by the floor. So this is uh, the pair of forces. Okay, third law force pair. Now in this condition there is no net force on it and the object is not moving at all. So let us apply some force on it and try to pull it. As we apply force towards left, like in the yellow arrow, in the direction of yellow arrow, we are applying force F to pull the box towards ourselves. So as soon as we apply a force, another force that is equal in magnitude and opposite in direction immediately appears, and that force is frictional force, as represented by Fs here. So if the block is not moving, this frictional force is called as static frictional force. That is why it is represented as Fs. So we increase the force, the frictional force, the static frictional force also increases, and this is equal in magnitude and opposite in direction to the applied force. And we keep on increasing our applied force, and frictional force will keep on increasing until a point comes when our applied force overcomes the static frictional force and the block starts to move. At this point, this static frictional force changes to kinetic frictional force, and we represent it with F and subscript K. Now let us represent it in the form of and friction, and the kinetic frictional force is always less than the maximum value of the static frictional force. Excuse me. Now let us observe it in the form of a graph. So on y-axis we have frictional force, and on x-axis we have time. We apply means on the same block we apply force F, and we keep on increasing our force F. As a result of that, our frictional force or Fs also increases with the applied force, with the increase in the applied force, and it reaches its maximum value, that is represented with Fs comma max, that you will see in the next slide also. So it reaches a maximum value there, as pointed out with an arrow, that this is the maximum value of the static frictional force. Then it starts to decline as soon as object starts to move. So during this time, when the static frictional force keep on increasing, object does not move, so unless it reaches its maximum value. After that, the frictional force decreases and continues to stay almost same at the same level, and at this point the object starts to move. So in the blue region the object is moving, and the frictional force is called as kinetic frictional force, represented with Fk, and this is slightly or little bit less than the static frictional force. So you have to keep in mind that as long as the object is in the state of rest and we are applying the force, that we keep on increasing and the object is not moving, the frictional force is called as static frictional force. It reaches to a maximum value, and after that it reduces and the object starts to move. Then the frictional force still exists there, but that is lower in value than the static frictional force, and it is called as kinetic frictional force. Okay, so the moving object has faces less friction than the static object. You must have noticed that it is harder to move an object at rest, but when it starts to move you have to apply a little bit lesser force than before. Now let us take a closer look at how friction works. So the friction comes into being when the surfaces of two objects are brought in touch together. But the more the surface is in contact with the other surface, the more the friction is. But at microscopic level, we see that there are some humps and some crests and some troughs, like some hills and valleys on each surface. So when they come in contact with each other, there is atomic interaction between them. So if for let us consider that the surface is perfectly smooth, if two objects have perfectly smooth surfaces and there is no air in between them, like for example in space, if two perfectly flat surfaces are brought in touch with each other, all of the atoms on the surface will be in touch with all of the atoms of the other surface, and if there is no even air in between them, then like in space, they will immediately become one piece of the surface. Like two metals, if there are two metals, they will become one piece of metal. The interaction between them will be so strong, and that is called as cold welding. So if perfectly smooth surfaces of two metals are brought in touch with each other in space, they will be cold welded together and become one piece of metal. But in reality, we do not have such smooth surfaces. Uh, Even perfectly flat looking surfaces will be rough and not as smooth at microscopic level, as you can see in the image here. So there will always be some humps and some curves on the surface. So these two, when they brought together, some part of them come in touch with each other and cold weld together. And when we try to slide them, so we have to apply a force to break their bond. So when we break them, then immediately they come in contact with other ones, then another ones, then another one. So this is like slip and break, like slip and break, slip and break. So first they make contact, then we slide them, then they slide over each other, then come in contact with next one. And because of this thing, we hear the sounds of squeaking. These slip and touch and then slip and touch again, this create the sounds of squeaking. And the harmonious sounds from the violin, means very melodious sounds, those are also results of the frictional force. So at some points these frictional force is disadvantageous and undesired, and other places and other events it is very much desired. You have to remember that the surface area, if the more surface area is in touch, there will be more friction. If less surface area is in touch, that's why you might have noticed that the glass very shiny glass, if there is very shiny glass, the friction is more with that. If there is rough or you are using a matte screen protector on your mobile phones, the surface is smooth and there is not as much friction. You will not feel as much friction on the screen as you will feel with the perfectly shiny and smooth glass. There are three properties of friction now. So the first property is that if a body does not move, the component of the applied force that is parallel to the surface is balanced by the static frictional force. Okay, that if the body is not moving, then the component of the force that is parallel to the surface on which the object is laying. Like for example, when we were pulling the box is a wooden box, the wooden box is laying on the floor. The component of the force which was along the floor, that will be balanced by the static frictional force only as long as the object is not moving. Okay, and the maximum magnitude of the static frictional force can be found out by this formula. Fs max is equal to mu s Fn, and this Fn is the normal force, and it will be equal to the weight component of the object. And mu s here, it is called as coefficient of static friction. And then next is when the body begins to slide along the surface, the magnitude of the frictional force rapidly decreases to a smaller value that is called as kinetic frictional force, and it can be calculated using this formula. Fk is equal to mu k Fn. So Fn here is again the normal force, which is equal to the component of the weight, and mu k is coefficient of kinetic friction. Okay, thank you very much. That is all for today.